Welcome back. Let's create the button event needed for our 4 router buttons. The device is our touch panel, DV-TP_audio router. And we'll use the N router buttons array for our channel. So, if any of the 4 buttons get pressed, it will trigger this button event. Since I want to track which button was pressed, I need to create a local variable to store this number. I'll create a local var and make it an integer and name it nIndex because it's going to track the index of the array. In order to assign it a value, I'll use getLast to grab the index number of the array of the button. Now, if for example the user presses button 103, getLast will return a value of 3 and assign that value to the nIndex. Keep in mind these 4 buttons need to be toggle buttons. So, if one of the buttons is on and the audio is routed, when you press the button again, it will go off and unroute the audio, and vice versa. We need to create a tracking variable to monitor the current route or unroute status of each of the 4 buttons. Because I want Netlinks to retain the value stored in the variable, I will scroll up and declare it in the Define Variable section. I'll name this tracking variable array nMatrixRouterStatus. Also, since I am tracking the status of 4 different buttons, I will make it an array of the size 4. Now I will return back down to the button event and put this variable to use. Remember from our previous lessons how we toggle? This tracking variable will only ever contain a value of 1 or 0. We simply say value gets not value. But it's a little trickier here because we have 4 buttons we're dealing with. If I just have the variable toggling without specifying an index number, it's going to toggle when any of the 4 buttons are pressed. That's exactly why we made this an array with a size of 4. So we can distinguish between the 4 buttons. We simply add the square brackets to the end of the nMatrixRouterStatus, and inside the brackets we specify which button number is going to toggle. That's the whole point of creating the nIndex, to store a number between 1 and 4 to represent which status we are toggling. Now, anytime a user presses a button, it will toggle the corresponding router according to that button index. Let's step through this one more time so we're crystal clear on what's happening here. For example, if button 103 is currently off or unrouted and I press button 103, nIndex will have a value of 3 stored in it because of the getLast statement. Then nMatrixRouterStatus sub 3, or the 3rd position of the array, will be set to 1 or on. Then if I press the button again, nMatrixRouterStatus sub 3 will be set to 0 or off. With that, all 4 buttons will now toggle on and off. If you understand that, the rest is easy. Now I just do a conditional based on the state of that variable and its index. I can simply write an if statement. If nMatrixRouterStatus sub nIndex double equals 1. So this means the button was just toggled on. Therefore, we'll send the route command inside a set of curly braces. Before we do that, I'll build an else if statement for when the button is turned off. Else if nMatrixRouterStatus sub nIndex double equals 0. And I'll open up a set of braces here as well for our unroute commands. To finish off our button event, we simply need to send either the route or the unroute commands to the blue 50. We'll start with the route commands. Send string dv bss underscore blue 50. sroute commands. But which one? Remember, there are 4 of them. Well, we know exactly which one to send. It's currently stored in nIndex. Therefore, inside the brackets, we'll put nIndex. The same thing needs to be done for the unroute commands. Copy and paste the send string statement and just change sRoute commands to sunroute commands. Our button event is complete. Make sure you compile and you don't have any mistakes. Now let's get into the main purpose of this exercise, parsing the returned strings to provide button feedback. In order to be efficient about providing feedback to the buttons by parsing the strings, we need to take advantage of the fact that we really only care about 2 bytes of data being returned to us. Take a look at the Blue 50 commands document again. Notice the strings coming back from the Blue 50 are virtually identical. Only the 2 characters returned in the 16th and the 17th index of the array are unique. Therefore, it makes sense to only look at these 2 characters instead of analyzing the entire string. Scroll back up to the data event. Since we already created an online event handler for the Blue 50, we just go below that in the same data event and add a string handler. We need to create some local scope variable, just so we can drop them into a debug later to make sure we are doing the string parsing correctly. First, let's create a local var, char array, to store the entire string coming back to us from the DSP. I'll call it sFromBlue50, and since we know none of the returning strings are longer than 18 characters, I'll give it a size of 18. If you read deep into the protocol document, you will see that the character in byte 16 is the status indicator of whether we're routing or unrouting, and the 17th byte is the unique checksum. So let's create 2 more local vars to store each of those characters. I'll create a local var char cStatusByte and another one called cChecksumByte. Each of these is only going to be storing 1 byte of information, and we should be able to leave the variable just the way it is written here. But we're actually going to specify a size of 1. We'll discuss why we are doing this in a few minutes. All right, now that we have all of our local variables created, the first thing we should do is load data.txt into the sFromBlue50 array. Like so, sFromBlue50 gets data.txt. Next, we will begin parsing our string. Let's use midstring to capture the 16th character and place it into our cStatusByte variable. cStatusByte gets, open parenthesis, midstring, open parenthesis, sFromBlue50, comma, 16, comma, 1, close parenthesis, semicolon. We'll use the same process for byte 17. cChecksumByte gets, open parenthesis, midstring, open parenthesis, sFromBlue50, comma, 17, comma, 1, close parenthesis, semicolon. And with that, our string parsing is done. We just need to use that parsed out data to set the button feedback. Because we're stacking together several possible conditions, of which only one can be true, the best choice is to use selectActive as we compare what came back to us against known routing data values. I'll walk you through the first one step by step. Then you can create the others on your own. First, add the select statement. Open another brace, then add the first active conditional. Open parentheses to enter the first part of the conditional statement. The first comparison that we want to do is to see if we are routing or unrouting. Remember, byte 16 will always be a hex 1 or a hex 0. So here, write cStatusByte equal to, open double quote, $0, 1, close double quote. Now, add the AND operator. Then the next comparison for the checksum byte. cChecksumByte equals to, open double quote, $1, 7, close double quote, close parenthesis, and add the ending colon. Now, if both of those resolve to true, then we have a confirmation back from the DSP that it just routed input 1 to output 1. Therefore, we should turn on button 101. To do that, open a brace and just type in on bracket dvtp underscore audio router comma 101 close bracket semicolon. On the next line, close the brace, and you can just repeat this for each of the remaining 7 responses. Pause this tutorial if you need time to catch up. Once you have all those, the code should look like this. Compile your code and fix any errors or warnings before you move on. While we do have working code at this point, there is one thing we need to discuss. Remember earlier, I intentionally didn't explain why we set the size of cStatusByte and cChecksumByte to 1? The reason is, if you had not specified a length, like you were probably thinking we should do, the compiler would have thrown you a warning. A warning would have been that you are converting a type string to character. Let's fix this and go through how to follow the best practice and prevent the compiler from throwing this warning. Go back up to your variable declaration and delete the size of 1 from each of those variables. Now you should have local var char cStatusByte and cChecksumByte. Since there are no brackets after these, they will each now hold a single byte or 1 character. Try compiling code now and you'll see the warning we were talking about. To clear these warnings, go down to the assignment statement and right after the get operator, add in typecast keyword so that you have cStatusByte equals typecast, open parenthesis, midstring, open parenthesis, S from blue 50, comma, 16, comma 1, close parenthesis, close parenthesis. And do the same for the checksumbyte. Now if you compile, you'll see that it clears out the warnings. The reason the compiler throws a warning if you don't use typecast here is that it thinks you may be trying to place multiple bytes of data into a single character, which, of course, is not possible, so data will be lost. And there you have it. This is all we need to parse the strings and set the feedback. Make sure you save your exercise source code file and close out of it before moving on. In the next lesson, we'll learn about for loops.